Today we're going to talk about zero and negative exponents. This is section 5-2 in your textbook. The essential question we're going to discuss in this section is, how do you simplify expressions involving the exponent zero and negative integral exponents? So first, let's look at some definitions. First of all, if you take any number and raise it to the zero power, your answer is going to be 1. So a to the 0 is simply equal to 1. Now if your exponent is negative, for example if you have a to the minus n, that is equal to 1 over a to the n. Another thing to understand is that negative exponents are considered to be non-standard, so therefore whenever there is a negative exponent you are going to want to change it to become a positive exponent. So let's look at some examples where we might use what we know about zero and negative exponents to simplify some expressions. So let's say we've got 3x to the minus 1 over y to the minus 2. I want to simplify this and so that there will be no negative exponents. Well, if you look, we've got x to the minus 1 in the numerator. Based on the definition of negative exponents, I can move that into the denominator and it will become a positive exponent. Similarly, the y to the minus 2 in the denominator I can bring up to the numerator, and again the exponent will change. So the result would look something like this: 3y squared over x. So we are fully simplified, we have only positive exponents, and that's our result. So let's look at another example. Here I've got 3a cubed inside parentheses raised to the minus 2, and that's in the numerator, divided by a to the minus 3, b to the minus 3 in the denominator. So if I want to change a negative sign to a positive sign exponent, I simply either move it from the numerator to the denominator or from the denominator to the numerator. The result would look something like this: a cubed, b cubed in the numerator, divided by parentheses 3a cubed raised to the positive 2 power. And this can be further simplified to get rid of the parentheses, and the result will look something like this. And this result can be further simplified by noting that we've got a to the 3 in the numerator and a to the 6 in the denominator, so I can get rid of some of that. I can get rid of that a to the 3 in the numerator, with the final result looking like b cubed divided by 9a cubed. So let's look at one last example. So I've got parentheses a to the minus 2b raised, the whole thing raised to the minus 1, and that's the numerator, divided by ab squared inside parentheses raised to the minus 2. So the first thing I'm going to do is take the parentheses and switch those around to make the exponents positive. We now have ab squared in parentheses raised to the positive 2 divided by a to the minus 2b in parentheses. Okay, we need to further simplify to get that a to the minus 2 out of the denominator, and also, if we square the parentheses in the numerator, the result will look something like this. But taking it a step at a time, I'm going to first get rid of the parentheses, which yields me with a squared b to the 4th in the numerator over a to the minus 2b in the denominator. Now I'm going to take the a to the minus 2 in the denominator and bring that up. And also we've got b's here that we can cancel, but let's just bring a up first of all. So now we have a to the 4th, b to the 4th in the numerator, and b in the denominator. One last step to simplify, and that is the fact that we have b's in the numerator and the denominator, which we can take care of and yield a final result of a to the 4th, b to the 3rd. Several steps involved here, but we got rid of all the negative exponents and we made other simplifications that we could. And so we end up with simply positive exponents and no further simplification that can be done. I would now like you to go to page 218 and do oral exercises numbers 13 through 16 and post your answers in the drop box. Thank you.